Today, in this lecture, we are going to discuss about vectors. There are a lot of topics that we need to describe as a student or as a teacher. A lot of topics I will be sharing to you, and your work is to understand those topics that I will be telling you. Okay, so first point is that our topic name is vector. In details, I am going to discuss about this in details for you. Uh, yes, this is a series wise. We will start from meaning of vector and we will end till the advance. Now let's start with the meaning of a vector. One thing I would like to add over here for you, if you don't do questions, then of course our understanding will not grow. I think so. Okay. So doing question is also compulsory. Doing question is also compulsory. Okay. So during this lecture, I will be questioning where I think yes, mm, this is where I should ask to you. Then I will ask. So right now I am going to ask a question to you. Tell me, uh, according to you, what should be meaning of a vector? Okay, those people who don't know meaning of a vector at all, don't worry. I am here to explain this. But people would know meaning of this word, so try to explain. I would like to see. I would like to watch your explanation. So okay, let me explain. Vector. Look, there are a lot of quantities in the world. Yes, and we are going to classify all those quantities into two part. So first part will be vector and second part will be uh, scalar. Okay, vector quantity and a scalar quantity. So here we are uh, classifying quantities into two parts. First part is vector and second part is a scalar quantity. Now question is, what type of quantities should be kept in the vector quantity, in the field of vector, and what type of quantities should be kept in a scalar field? This is a question right now. So I would say here we have a definition for both, for vector as well as for a scalar. So definition of a vector is any quantity, okay, any quantity, if that quantity can be measured. If you are taking a quantity and you are able to measure that quantity, so any quantity which can be measured will be vector quantity. This was a complete definition of a vector. Clear? You can take any quantity if you are able to measure that quantities. Now you can put you can say that yes, this measurable quantity is a vector quantity because we are able to measure. That's all. Okay. I will give you example. Don't worry. Now what about the scalar quantities? Okay, just opposite of a vector quantities. Any quantities which cannot be measured is a scalar quantity. This was very basic definition of a scalar and vector. But don't worry, we will move towards this. Then you will think yes, we are understanding something better. No, here I will not write a scalar because our focus will be on vector. That's why. So little bit information about a scalar I am telling you. So a scalar is also quantity. Okay. So in the scalar quantity we just keep those quantities which cannot be measured. Okay, cannot be measured. So those quantities will be in the field of a scalar quantity. That's it about a scalar. Okay, now it's a time to take examples for a vector and for a scalar. So for that displacement, uh, velocity, acceleration, force, this, I selected this. Okay, there are more examples of a vector. So just I said what displacement, velocity, and acceleration. So all these are examples of vector, not scalar. Okay. So remember, displacement, velocity, acceleration, force are examples of a vector because we can measure displacement. Okay. Uh, yeah, we can measure displacement. Hmm. But hold on, physical quantities and unphysical quantities. I have told you wrong. Okay. So whatever I was explaining was about physical quantity and non-physical quantity, not about vector and scalar. So non-physical quantities are those quantities that cannot be measured, and physical quantities are those quantities that can be measured. Now we are able to discuss about vector and scalar. So here, vector is a quantity, a scalar is also quantity. Clear? Any quantity which is providing, any quantity which is providing a value, unit, and direction is vector quantity. Clear? Direction will matter for vector. Direction will not matter for a scalar. Got it? Got it. So here I would like to highlight here direction, magnitude. So uh, have a look over here, magnitude and the direction. A scalar is also quantity, but a scalar does not have direction. This is what is the difference between a scalar and vector. Okay. Remember, vector will also give magnitude, and a scalar will also give magnitude. But vector will provide direction as well. Okay. But a scalar will not provide a direction. Clear? Now we will see types of vectors. Okay, types of vectors. Sorry, representation. Before we understand the types of vector, let's see representation of a vector. Representation. How to represent a vector? So to represent a vector, just draw a line. This line, segment line. This line is known as a segment line. Now look at over here. It is not a vector. Okay, this is not a vector because only it is telling you a magnitude. This how much is the length of this line is magnitude. It can be 2 centimeter, it can be 5 centimeter. We don't have an exact number. When you will apply this arrow will have a voice. It is telling you that I am providing direction. I am providing direction. Who is providing? So arrow is providing direction. Along this segment line is will not be providing a direction. Along line is for only magnitude. Okay, but this arrow is for direction. Is for direction. So this A, okay, A. If you apply this vector over A, here you are saying that this is a vector A. This is a vector A. Clear? It is too much basic. Now, if you remove this, this will not be valid for vector. Now, here I have applied this mode. It is now this complete is magnitude. Even there is a vector sign, vector symbol, but still it is a scalar. Yeah, a scalar because it, it does not have my direction. That's why. So this is only magnitude. It is only magnitude. Why do we apply this two parallel lines? We will discuss later about it. Right now, understand that if you apply this parallel line with a vector, then it will convert itself into magnitude. Into magnitude. To convert any vector, just apply this mode. This will be your magnitude. Clear? We have seen how to represent any vector. So that is how you will draw a vector symbol. Okay, symbol of a vector. I hope you have understood something in this part. Now I am going to move ahead. Uh, one point more, one point more thing I would like to explain about this arrow. Here, this side, this end, this side, this end is known as a tail, and this arrow will be known as a head. So here, and this a tail, clear? This a tail. So this side is for tail, and this side is for head. This is a point that you have to remember. Okay, it's not a difficult, it's not a rocket science. Okay, it's a very simple. Without arrow side will be tail, with arrow side will be head. Okay, that's it. It will help you in upcoming questions, in upcoming topics. Clear? Clear? Now we were understanding about this. What if I say this vector A with a mode is equal to A? Here, this A is a completely magnitude. It does not have a this arrow, so that's why we can say this is a complete magnitude. Magnitude, okay. So remember, magnitude is a combination. If you wanted to define a magnitude, then I would say magnitude is a magnitude is a combination of it is a combination of unit and number. Unit and number. 5 kg. So 5 is a number. Kg is a unit. Kg is a unit. Now here, have a look over here. Here I am saying this is equal to this. It means when we applied this parallel line, here it converted itself into magnitude. That's why. So this completely is a magnitude. Okay, it's not. It does not have this part. This does not have a direction because we have applied this parallel line. That's why. And this parallel line is called as what? It is a what? We call it as a mode. Okay, as a line. So this can be written as a. Okay, this can be written as this. So both are equal to each other. Okay. With some examples, we will have more clarification about this. Don't worry. Just I am providing little bit information about this. Little bit information about this. Now it's a time to understand types of vector. Types of types of vectors. First, let's start with negative vector. Negative vector. Negative vector is a vector. But now here we can see a word is added with a vector. So that's why something will be different from the a vector. Okay. So here I think direction is opposite. Direction is opposite. Magnitude. Direction means if this is in this direction, so second will be in this direction. Now we can say this is going positive and this is going negative. What do you think? Yes, we are correct. We are correct. We are correct. Now look at whole. How to define this negative vector? Just as a simple. It is a vector which has same magnitude. Here we are taking two magnitude. Okay, just to define this negative vector. So let's consider we have two vector. So magnitude of both vectors are same, but direction of both are opposite, like this. Okay, magnitude is the same, but direction is opposite. It is a definition of a negative vector. Okay. Now next type, equal vector. Equal vector. What do you think about equal vector? A vector which has, so here everything is equal because equal word is added with the vector, so everything will be equal. Direction will be equal. If hold on, 5 kilometer in east direction, in east direction. Now next 10 kilometer, 10 kilometer in west direction. What are you understanding over here? Here you can see what is happening over. Something covered distance in east direction. How much? 5 kilometers. And other thing covered a distance of 10 kilometers, but in west direction. So direction is not the same, and the magnitude is also not same. That's why this is not a definition for equal vector. Here magnitude should be same. Everything should be same. Direction should be same. Here you can see. Here you can see. This is one vector and this is another vector. This is one vector and this is another vector. Okay. Now here we have to understand is that magnitude is the same and direction is also same. That's why we can say this vector is equal to vector. Okay. So this is the definition of equal vector. Everything is the same. Magnitude is the same. Direction is the same. Is the definition of equal vector. It is done. Now next collinear vector. Look here, co means compound, two or more. What two or more? Lines. Two or more lines. So here vector. This one vector, this another vector, this third vector, this fourth vector. All these are in one direction. You can see here. This all these vectors are in one direction on a single line. Okay. So two or more vectors, if they are in one direction on a single line, is a definition of a collinear vector. Clear? Here number of vectors can be more, but they should be in one direction on a single line. So single line we are imagining Okay, we are imagining. So I hope this part is clear. Did you have you ever heard about null vector or zero vector? Null vector or zero vector. Zero vector. Have you ever heard about this? Look here, from this word you are crystal clear. From this word, we are crystal clear about this. It is saying a vector which has zero magnitude, no specific direction, no specific, no explained direction. So there is a nothing. There is a nothing. Here you would say a vector which is nothing, which does not have nothing. Okay. No, another vector which is a type of vector is very important for physics and for also mathematics, and that is unit vector. Unit vector. You will see more questions based on this unit vector. Uh, I am telling you importance of unit vector. It will come a lot of times. So unit. From this word, we have to be crystal clear, which is this unit, which means one in this context. So magnitude is one. Okay, magnitude is one, and there is a direction. So remember, magnitude will be magnitude is one unit, which means one. Now question is, if a magnitude is one, it is always one. So why is it given for us to understand this, to study this? So answer is that it tells you a direction. It will only tell you direction. That's it. For example, this I cap, this I cap. Okay. Here one is added, one is added, and cap is showing its direction. Where is it present? Clear? We will say this I cap, J cap, K cap. Just after explaining something, some concept. So this vector is used to highlight direction, not magnitude. Magnitude is always one. Okay. Now this this is known as a cap. This is a symbol of unit vector. This cap is a symbol of a unit vector. Here, this cap is a symbol of a unit vector. This is how a unit vector is represented. Now our question is, this will be equal to vector A. I think A upon this vector. I think so. Am I correct or not? Either it would be upper or it would be downward. I am not confirmed, but yes, this will be A cap will be something like that. This will be equal to this A upon more of A. Here we know that this is nothing but magnitude. This is also magnitude. This will cut this. We will have 1. So this is equal to 1. Okay. Here we are. I am saying that this A cap is equal to A upon uh, mode of vectoring. In this part, I was saying that this is equal to A. Same here we are saying that this is, let's say A is a 1 and this is also 1. This will cut this, we will have 1. And we know that it has a 1 magnitude, that's it about the unit vector in this section. In details, we will explore this in separate lecture. Don't worry. Okay. Now, next thing, let's say what are the things which we need to understand. Now here, what is it? What is it? Here, this line is a y, and this is a x, and this is a z. We have a three. We have a three lines. This one x axis, this y axis, and this is z axis. It means you have three dimensions. Three dimensions. When you take this three axis, it means you have a three dimension. When you select this two axis, any two axis, it means you have a two dimension. Okay, this one, this is second, and this is third. We are going to connect this with a vector. Till here, we are already crystal clear about this. Now, in the language of vector, we call it this axis as a I cap. I cap. Okay. In the language of a vector, this x-axis is known as I cap, and this y-axis will be known as z cap, and this z will be known as k cap. Okay. K cap. Whenever you are going to represent this I cap, here you are saying that yes, this much magnitude is in x-axis. That is what you are saying by representing this I cap. Okay. Let's say you are representing this z cap. Here you are saying that this much magnitude, this much force are being applied on a box in y axis. This is what you are saying just by applying this z cap. Okay. Now next axis we have which is a z axis. So this k cap is for z. It is fixed. We will not change. You cannot say this I cap is for z. This z cap is for x. No. It's a rule. Okay. If we will change like that, then we will have a lot of confusion. So remember, this is always for x. This z cap is always for y axis. This k cap is always for Z axis. Clear? I hope you are clear. Clear. And this section part, intersection part is known as origin. Origin. Now let's just see this cos theta and sin theta. If this horizontal line, if you are considering this horizontal line, so here, remember, you will have to take two components, this one and this is second. Either you can select this one and this one. Now here you can see this is a parallel. Let's say we are selecting these two components, and here we can easily see that this is a parallel, this is a horizontal. So that's why we will say this is going to, this is going to, this will be what, sine. This will be sine, x is sine theta. Okay? No, x cos theta, x cos theta. And this vertical will be for sine theta, okay? Sine theta. Vertical component. Always there. This y will be, this is a vertical, that's why we are saying here y sine theta, and this cos is for horizontal. Horizontal. Okay. Now from this discussion, let's understand next topic, which is a position vector. Position vector. This was too much basics about vector in 3 dimension. Now position vector. Okay. Position vector. From the word which is a position, you are understanding that we are going to see what is the position of a vector. Let's say there is a vector, this point, this particle, we are considering it as a vector. Okay. So here we are saying this particle is also moving in x-axis. It is also moving in y-axis. This is also moving in z-axis, because it is present in 3 axes. That's why. Now here you are saying that it is also covering x distance, y distance, and z distance. Z distance. So position of this vector is where? Where is the position of this vector? When we find the position of this vector from the origin, like that. Position vector of this is from the origin. So this line which is from the origin till the particle, this complete is a position vector, and we can name it as a R. Okay. Here we are saying vector, so this arrow will come. Now try to see. Here you can see it covered, this particle covered this much x axis, this much distance, and this much distance y axis. What are you saying? Here this is y axis and this is x axis. Here you can see. It can be 5 centimeter, it can be 4 centimeter. Till now you have seen how to define position vector. Okay. Any vector which is present in dimension, and a line which is coming from the origin, and it is ending till the vector, till the particle. This line is a completely position vector. Now, next question is, what is the distance between this? Okay, between this distance. This is where a formula will come. What is the distance from this horizon till the this particle? And here you can see we have a triangle, and in this triangle, this is nothing but right triangle, right triangle. It is making 90 degree. That's why we are able to apply Pythagoras theorem. But in this part, this is a little bit different. Normally, we used to say that this is nothing but a square is equal to b square plus c square. H square is equal to p square plus b square. This is what we used to use in our ninth class, no, in 10th class. But in this part, it is a little bit different from this. I would say logic will be same, but something structure will be uh, something else. Structure will be something else, but rules will be rules will be same. So what are you looking over here? Have a look little bit. Let's say this is B. So OB magnitude, or you can say R, is equal to nothing but this one x square, this second y square. This is for two dimension. If you are taking this third as well, you can also write this. Now here you have taken three dimension. Okay. Here you can see we have applied this mode. It means we will get a value which will be telling us that this distance. Let's just say answer is coming 5. So here you are saying this is 5. We don't know in which axis. Okay. Okay. So this is formula. When we will use this formula, we will get the distance from this till this. Clear? If you remove this mode, then something we will have to apply over here. When this mode will be removed, then something will be applied in this side. Clear? So mode of vector r is equal to this is formula. From this formula we will get magnitude of vector r. Now, here look at we have two vectors, a vector dot b vector and cos theta. Now, dot product vector. We are understanding dot product vector. It means this dot, when we are applying this dot, this completely will be known as a dot product vector. We are multiplying product, which means multiplying. So this multiple this cos theta. So cos theta we are taking because here we have a angle. That's why two vectors are making angles. Of course, two vectors will make angle. That's why this cos theta is present over here. Now look at over here. If you remove this dot, then it will be AB cos theta. This will be AB cos theta. Here you can see this A is a magnitude, this B is also magnitude. And this cos will tell you that we have completely dot product of vector. Clear? Dot product vector. Okay. Now here I will tell you about cross product vector. Cross product vector. But one thing, I into I. This part. Look at over here. Look at over here. Remember, whenever you have this dot, and you have two vectors, which is I cap dot I cap. Okay, I cap dot I cap. So this will be equal to 1, and this j cap dot j cap will be equal to 1, and this k cap dot k cap will be equal to 1, because the post 90 cos 90 is equal to 0 cap. So this will be 1, then we have a dot product. But what if we have I cap cross j cap in this case? I cap j cap into k cap. So what is the cross product? Cross product is the same. Just we change this, we replace this cos theta by sin theta. So A vector multiple B vector. This is sin theta is telling you that this complete is a cross product. Okay, if you want to remove this, then it will be nothing but AB sin theta. Here we know that this is magnitude, B is also magnitude, but this is sin theta is telling you that this is a complete cross product vector. Cross product vector. Okay. Now I want to show you magic. I want to show you magic. This, if you are rotating in this direction, which is anti-clockwise, so this will be positive. If you are rotating in this direction, which is clockwise, so this will be negative. Now here you can see we are starting I, then j cap. So of course next will be k cap. So that's why here it is nothing but k cap with a positive. So anti-clockwise is a positive. Same here, k cap, no, j cap, then k cap, then it will come nothing but I cap. I cap. Now next we have k cap, then I cap. Of course, then next will come j cap. So here rotating will matter. If you are rotating anti-clockwise, then you will have to apply this addition sign. Now, what about if we rotate negative in clockwise? Then here you will see I cap, then k cap, then j cap, j cap, then I cap. What is happening over? All these components are showing that we are rotating in clockwise direction. In this case, this we are rotating in negative direction. Okay, in negative direction. So this. So here you look at over here. I cap, j, I cap, k cap. Then next will come j cap. But twist is that we are moving in clockwise. That's why negative sign will be compulsory to apply it. Okay. Now next k cap, this k cap, then next j cap. So of course next of this will come I cap. Okay. No. Okay. We agree. Now sign should be positive or negative. Of course negative because clockwise. Same here. Minus k cap. Minus k cap. Okay. From this part, we understood something, which is nothing but if components are rotating in anti-clockwise, then we will have addition sign with the next component. Okay. But what if components are rotating in clockwise? In this case, next component will have negative sign because of direction. Because of direction. Now, what about this? If we replace this dot by vector, then what will happen? Nothing will happen. Here we had this one. If we are replacing this dot product by vector, of course this will change itself by zero, Okay. So in the case of vector, cross vector, cross vector. So I cross I cap, J cross J cap, K cross K cap. In this case, this I cap cross I cap will be zero. This 0 is coming, this 1 is coming, it is all of this 1 is a depend on theta. Okay. This 0 is a depend on trigonometric theta. Okay. So this is j cap multiple j cap is 0. This k cap multiple k cap is 0. This will be 0 in the case of cross product vector. Cross product vector. I hope you have understood something. Now I have some question. One question for you. One question for you. Let me write. Now this is question. Now tell me what should be answer for this question. What is given? Given is A, then B. A is 2y plus 3z. There is a particle. Let's consider A as a particle. It is moving in x-axis as well as in y-axis. As we saw concept, so according to concept, this 2 2 is a distance. Okay, 2 is a distance in x-axis and 3 is a distance in y-axis. So 2 plus 3. But here we are observing that a particle is moving in x-axis. It moved in x-axis with 2, and at the same time it moved 3 meter in y-axis. This is what we are observing. Now next B, next particle, it moved 1 meter in x-axis, 1 meter in y-axis. So the component of vector A, it is saying that A is nothing but this is vector, B is also vector. So component of vector A along vector B. So A with B is what? Is a what? So here it is nothing but, first of all, we will have to see what is the dot product of A vector and B vector. So A vector B will be nothing but 2y and then 2y will be 1. So 2 plus answer is this much, root 2. So we have 2y plus 3z into I plus z. So what is happening over here? 2i into I plus 2i into z into z, and then we have 3z into I plus 3z into z. Here we can see this will come as a 2, then this is completely 0. Next we have this is also completely 0, and this will be nothing but 3 because z dot z is 1. So finally answer is coming as a 5. A dot B is 5. In the case of a dot product, this Ij will be 0, but in the case of a vector product, this Ij will be, I think Ij will be k cap, yeah? So right now we can see this Ij is equal to 0, this is Ji is equal to 0. Now what about here, this A is along vector B, so that's why mod this will be nothing but a square this I square plus J square. This here we have how much? Magnitude is how much? 1. So 1 square plus 1 square. This is completely root of 2. This is our answer. 5 upon root 2. 5 upon root 2. Here it is telling you that component of vector A, this is upon B, along vector B, along vector B. Clear? Clear? So here, can you see that A is equal to B? A is equal to vector of a mod B. So 5 upon root 2 is our answer. This is the complete answer. Look at over here. An angle of 60 degree to the horizontal if its rectangular component in the horizontal direction is 50. Did you understand till here? Till here. Now, next question. I was telling you one thing which was incorrect is that this dot product, this dot a scalar dot product, this dot product is not vector. This is a scalar dot product, and cross product is vector. So cross product vector, dot product a scalar. Okay. Now next question. Let's see. Now, it's our next question. This is a complete. Try to understand it. This is all about understanding. This question is all about understanding. It will tell you that how do you think about this question. Yeah. This is based on concept. If the scalar and vector products, we have seen a scalar dot product and vector cross product. So this is saying a scalar and vector products of two vectors A and B are equal in magnitude. Okay. Then the angle between the two vectors is for a scalar we know for this I think it should be nothing but cos. This is cos. So for a scalar is what cos theta and 4 vector, 4 vector, 4 vector is a sine theta. Clear? Sine theta. Okay. Now let's see. We have magnitude of both are equal. So A dot B, this is a scalar dot product. So cos theta, and we here in this is equal. Kishan is saying this is equal to A cross B sin theta. In here, whatever we wrote is by the equation, is given by the equation. Now here you can see what is happening over here. What is happening over here? I have told you that it can be written as AB cos theta, and this can be written as AB sin theta. Now you would ask to me that now what's the difference between this in this step? So here this is still telling you that it's nothing but a scalar product, and this is still telling that it's nothing but vector cross vector product. Okay? Because of this is theta, this is theta. Cos is for a scalar, and this is sine is for vector cross. Now AB is the same. This AB, this AB, and this is sine upon cos theta. Here you can see this will cut by 1, and 1 will be as it. Now you know that sine theta upon cos theta is a tan theta. So what is the value of that theta when we will put over here, and it should be equal to 1. So you know that it is nothing but tan 45 is equal to tan 45 degree. Value of tan 45 is 1. So Kishan was asking what is the angle between these two vectors if the magnitude of these two vectors are same. In this case we can say that angle is nothing but 45 degree, where its magnitude is equal. In this case theta will be 45. Did you understand? Here you can see, remember this part can be written as like that, but this cos theta is about scalar dot product. This is sin theta is about cross product vector. Okay. After simplifying this, we got this theta as a 45. Till here, I hope you have understood a lot of things. This is over.